Welcome back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile some of the most amazing, jaw-dropping scientific developments in the area of science and technology. Things that will impact directly on your life. And in this hour, it's open mic. That's right, it's open mic on Science Fantastic. So let's move right on and take the first listener phone call.
Hi, Dr. Michio. My name is Kayal Carres, and I have a question for you. So, us as three-dimensional human beings, do you think with the help of computers we can see the fourth dimension? And if so, when do you expect for that to happen? Thank you.
Well, you asked a question that I actually addressed in my earlier book called Hyperspace, where I talk about the fourth dimension. Well, first of all, we live in a three-dimensional world. We can move forward, backward, left, right, up, down. But have you ever tried to leap into the fourth dimension? You can't do it. When I was a child, I used to read a lot of science fiction, and a lot of it dealt with higher dimensions. And so I thought to myself, if I could jump fast enough, hard enough, in different directions, maybe I can go into the fourth dimension. Nope, can't do it. We live in a three-dimensional world. Then, of course, along comes Einstein, who says time can be viewed as a fourth dimension, a fourth temporal dimension, which creates a fabric of space and time. So what we used to call the fourth dimension is now called the fifth dimension. We have three dimensions of space, that is length, width, height, one dimension of time, and the fifth dimension, which you cannot visualize, is used to be called the fourth spatial dimension. Now, artists, of course, have tried to capsulize these higher dimensions in their artwork. For example, Salvador Dali, the surrealist painter, painted Jesus Christ crucified in the fourth dimension. That's right. He was fascinated by the fourth dimension. That's why he had melted clocks. Melted clocks represent his attempt to bend time as a fourth dimension in his artwork. That's why he had melted clocks. And then he had Jesus Christ crucified on a tesseract. A tesseract is an unfolded four-dimensional hypercube. You cannot visualize the fourth dimension. You cannot leap into the fourth dimension. However, you can visualize cross-sections and unravelings of the fourth dimension. So let's say I take a cardboard box and I were to unravel a cardboard box. What do I get? Well, I get a cross. I get 6 squares arranged like a cross that could be folded up. So if I have a hypercube that is a four-dimensional cube, and I can unravel it, it would be a three-dimensional cross. And bingo, that's what Salvador Dali tried to typify in his famous work, Hypercubicus Crucifixion. That is, Jesus Christ crucified in front of a hypercube. Now, then the next question is, who lives in these higher dimensions? Well, theologians have had a crack at that because theologians since the time of Galileo were embarrassed whenever someone said, well, I just bought a telescope. I looked up to find heaven, and I couldn't find heaven. No angels, no demons, no firmament up in high, no cherubs. It's just stars. Well, that was very embarrassing because the church had to find out where is heaven located. So at the turn of the century, around 1900, many theologians began to say that heaven is located in the fourth dimension. So let's think about the fourth dimension for a moment. Let's say I have flatland, that is people living on a tabletop, and they're two-dimensional, like cookie men. And they can move left, right, forward, backward, but up into the third dimension. Up is beyond their capsulization, their visualization. They cannot visualize up because they can only live on a two-dimensional plane. Now, we live in the third dimension. If we get one of these cookie people and peel them off the surface of a table, what happens to them? They disappear, and they can reappear someplace else. They could get out of jail. Jail for a flatlander is a circle. If you draw a circle around the Cookie Man, he cannot escape. And think about it. Who lives in the fourth dimension? Ghosts. Well, at the turn of the century, that's what people thought. Ghosts live in the fourth dimension. So let's take a short commercial break. And after that, believe it or not, let's talk about the science of what some theologians believe is the theory of ghosts living in the fourth dimension. Welcome back to Science Fantastic with Professor Michio Kaku. Well, before the break, we had a question. Can we move in the fourth dimension? And the answer is no. Sorry about that. We're stuck living on a three-dimensional world. However, our mind can visualize what a four-dimensional world might look like. So let's take a look at two-dimensional flat people, cookie people, living on a tabletop that cannot visualize the world of up. Up is beyond their comprehension. They can move left, right, forward, backward, but up makes no sense to them. However, we can peel them off their world and then put them someplace else in their two-dimensional world. They would literally disappear from sight, reappear someplace else. And then if I put a circle around them, that's a jail. They cannot escape from a circle. They bump into the circle every time they move left, right, forward, backward. But we laugh and say, ha, that's stupid. I mean, all you have to do is jump up and jump out of jail. Now, think about it for a moment. What kind of being has the capability of disappearing and reappearing someplace else? What kind of being can escape from a jail that is escape-proof? Think about that for a moment. Who can walk through walls? Who can escape the sturdiest prison? Why, the answer given by theologians 100 years ago was ghosts. And that started a romance between people who believed in ghosts, believe it or not, and the fourth dimension. Get a copy of my book, Hyperspace, and I trace the history of that. Even Sherlock Holmes was dabbling in this concept of the fourth dimension. H.G. Wells, they wrote about the fourth dimension and the possibility of ghosts and higher angels living in these other dimensions. In fact, H.G. Wells, who also wrote War of the Worlds and many other great science fiction stories, like The Time Machine, had another short story where an angel from hyperspace falls into our world by accident. And so theologians have found a very convenient place to put heaven, ghosts, demons, and whatever, and that is the fourth dimension. Well, sorry about that. We physicists don't believe that you can move freely in the fourth dimension. However, I work on something called string theory. In fact, I'm the co-founder of one of the main branches of string theory, which is string field theory. In string theory, we say that the universe started in 11 dimensions, not 4, but 11 dimensions. That our universe is a bubble, a small three-dimensional bubble that's expanding in a much larger ocean of nirvana, and that is hyperspace. And so many children ask the question, Mommy, Daddy, if the universe is expanding, what is it expanding into? Think about that for a moment. Everyone believes in the work of Einstein, who says the universe is expanding. Well, that's nice. And then the question is, what is it expanding into? Well, it's expanding into another dimension, hyperspace. It is the 11th dimension. So what happened to these other 7 dimensions? Where are they? Why can't we move in these other 7 dimensions? And the answer is they've curled up. They're so small that we cannot visualize them anymore. And we're stuck. Sorry about that. We are stuck in the 3rd dimension. Well, as I said before, if you want to know more about hyperspace, about these other dimensions, this is not science fiction, this is not theology, this is the most advanced physics and cosmology that we have today. Get a copy of my earlier book called Hyperspace. Okay, well, let's move right on now to the next listener phone call.
What is the origin of string theory? Thank you.
Well, you ask a very profound question. The origin actually goes back 2,000 years. 2,000 years ago, the Greeks asked a very simple question. What is the world made of? And they said, well, there must be a smallest object that you cannot cut. You cannot cut it, meaning atom. A means cannot. Tum means cut. And so atom means that which cannot be cut. But then also, in addition to Democritus, we also had Pythagoras. Pythagoras looked at the violin string, the strings of a lyre, and said that that's mathematics. The harmonies, the thirds, the fifth, the chords that we find in music must be a byproduct of the resonances of a vibrating string. Bingo! He was able to work out the mathematics of music. Think about that. We've had music ever since we left the forest. But the Pythagoreans, 2,000 years ago, worked out the mathematics of harmonies, the mathematics of octaves. Like, why do we have 8 notes in an octave? An oct means 8. Why 8? It's all because 8 is the number of ways you can divide a string. And so string theory got off the ground 2,000 years ago. But what happened after that? Nothing. For 2,000 years, scientists were stuck. Because what can you do with it? Atoms are too small to be seen. Strings, that's a very nice idea, but how do you explain the diversity of matter in the universe? Well, fast forward 2,000 years to the 1900s. Then we were able to split the atom in half. And then we began to realize that atom was a misnomer. You can, in fact, cut atoms into subatomic particles like protons. And then if you smash protons apart, what do you get? More subatomic particles like quarks. And then the question is, does it really stop there? Or does it keep on going like an onion, one layer after the next, after the next? Well, this is where string theory comes in. Because string theory says, why do we have all these god-darn subatomic particles? We have quarks, we have leptons, we have antiparticles, we have Yang-Mills particles, we have gluons, hundreds of subatomic particles that I had to memorize to get my PhD from Berkeley years ago. Why so many particles that cannot be cut? Well, this is where the Pythagoreans come in, because Pythagoras, 2,000 years ago, said that a simple object like a string allows you to explain all the thousands of notes, sharps and flats, that you find in music. So the resonances of music correspond to, in some sense, subatomic particles. So in other words, string theory says that the electron is not really a dot at all. If you were to peer into an electron, you would see that it's a rubber band. A tiny rubber band that's vibrating, but if you twang it in a different way, the rubber band turns into a neutrino. You twang it in another direction, and it turns into a quark. You twang it again, and it turns into a gluon. In fact, if you twang it enough times, you get all the subatomic particles that we've cataloged for decades by smashing atoms apart. So in other words, subatomic particles are nothing but the musical notes of a very tiny string. What is physics? Physics is the harmonies you can play on these vibrating strings. What is chemistry? Chemistry is the melodies you can play on vibrating strings. The universe is a symphony of strings. And then what is the mind of God that Albert Einstein searched for 30 years of his life, from 1925 to 1955? He searched for the mind of God. Well, we now have a candidate. The mind of God is cosmic music resonating through 11-dimensional hyperspace. That is our best understanding of how the whole shebang is put together. And again, if you want to find out more about this, get a copy of my earlier books, Hyperspace and Parallel Worlds. Okay, well, let's move right on to the next listener phone call.
Hello, my name is Kenneth, listening from California on the Genesis Radio Network. I would like to ask two questions for Mr. Kaku. First, scientists say that they do not know why humans sleep, but I think the reason should be obvious. At night, Homo sapiens cannot hunt and gather. Therefore, in order to conserve energy, they need to sleep. As a result, when we developed into civilization, we still needed to sleep at night. This is the same reason why the moon influences people's behavior. More light means the ability to hunt at night, so humans and other animals are more aggressive and more likely to have sex during moonlight. Why isn't this obvious to scientists? Second question I have is the fact that photons are used to measure electron positions and speeds in quantum theory. This results in the uncertainty principle. However, what if gravitons or gluons were used to detect electrons instead of using photons to detect them? So if you use gravitons as your so-called light beam instead of using a photon in order to detect the electrons, would this silence the uncertainty principle? Thank you for your time.
Well, actually, scientists would agree with you that sleep is a way for us to conserve energy, but that's not the question. The question that divides scientists is, why do we dream? Do animals dream? Why do we dream? Well, first of all, when we dream, we have what is called rapid eye movement. Your eyes vibrate very rapidly, and that's very easy to see with a brain scan. And it turns out that animals like cats and dogs will also have REM sleep. So it's a theory that we cannot prove, but it's a theory that even dogs and cats can dream. And then the question is, why? Why do we dream? It sounds like a waste of time, right? Well, if I have a brain scan and you brain scan the brain when it's dreaming, you find something interesting. First of all, blood flow to the prefrontal cortex right behind your forehead drops to zero, meaning that you are not conscious anymore. And your fact checker, which is right behind your eyeballs, that checks for anomalies in common sense and what you see around you. And that's also shut off. That's why dreams are fantastic. That's why dreams violate the known laws of common sense and science, because that part of the brain that governs common sense is turned off. Well, what's turned on? What's turned on in your brain when you dream is the center of your brain, which is the amygdala, or the emotional center, and that contains nightmares and fears. That's one reason why many of our dreams are not dreams of fluffy animals and vacations and nice thoughts. That's why many of our dreams are rather troubling, nightmares, because the amygdala controls many of our dreams, and the amygdala also controls nightmares. So you realize that the front part of the brain, which governs reason and logic, is shut off, but the center part of the brain remains quite active, and that's why you dream. But then the next question is, what do we dream about? As I said before, we dream about troubling things because it's the amygdala that is activated. But then the question is, why? That's the mystery. There's one theory which I think has some credibility and that is the brain tries to make sense of things, of all the memories that took place during the day. Well, let's take a short commercial break, and then we'll ask the question, can robots dream? What does artificial intelligence say about dreaming, and do robots dream? Think about that. This is a very active area of study. Welcome back to Science Fantastic with Professor Michio Kaku. And before the break, we had a call saying, what's behind sleep? Well, I think scientists agree that sleep is a way to rest and to recuperate, but why do we dream? That's what divides scientists. Some scientists say that it's nothing but the accidental flaring up of the amygdala, which controls troubling and nightmarish type thoughts, and that lights up when you dream. But why that type of dream? Well, it turns out when you build robots, you build what are called learning machines. These are called neural networks. Neural networks can actually learn very slowly, but they do learn by repetition and by practice. And then what you find out, interestingly enough, is that when these learning machines saturate, that is, when they learn too much, then they go into a different kind of state of consciousness where they can't learn anymore. And memories then begin to drift, and they begin to try to make sense of some of these memories. That's what we think is the origin of dreams. We think that animals and humans are learning machines, neural networks that are flooded with memories, and we can't learn anymore. And just like a file cabinet, we have to make sense of these dreams and reorganize them, just like what robots will do when they try to learn things, and learning is saturated by too many memories. They have to make sense out of it. And so that's one reason why we think that dreams not only are dreams that are nightmarish, but dreams also that try to make sense of troubling events. That is perhaps the origin of dreams. Well, once I interviewed at Harvard University one of the deans of dream research. For many decades, he's researched the nature of dreams, and I asked him about what about all these books by Freudian psychologists who have deep meanings in dreams. And he laughed, and he said, well, that's the fortune cookie theory of dreams that he does not agree with. Dreams can be explained, he said, by science, rather than appealing to mysticism. Okay, well, let's move right on to the next listener phone call.
Yes, hello. This message is for Dr. Michio Kaku. I have a question. It is, do you indicate the four fundamental forces of the universe as affirmative when speaking about the aging process and the digital and biological afterlife?
Okay, well, you have several questions in one, so let's try to break down the pieces. Even the previous caller asked about gravitons, and so let me explain. There are four fundamental forces that we think rule the universe. We've looked for a fifth and couldn't find any, but we think there are four. First of all, there is electricity and magnetism, which lights up our cities, makes possible television, radio. That's the first force, and what governs that force are photons. Photons are particles of light, particles of electricity, particles of magnetism, and photons interact with electrons, giving us television, radio, lasers. Next, we have gravity, which keeps us anchored to the floor, which holds the solar system together, and we think it is mediated by gravitons, tiny particles of gravity. We've never seen these, by the way. If you ever detect a graviton, you will win the Nobel Prize in physics. But we do believe that these gravitons exist, and when they average out to give you Einstein's theory of general relativity. Then we have the nuclear forces, the two nuclear forces, the weak and the strong. And the weak force governs radioactive decay, and the strong nuclear force holds the proton together, and the nuclear force explains why the sun shines, why the stars twinkle. So we think that four fundamental forces rule the world, but why four? Well, it turns out there are four fundamental theories that you can embed inside string theory. String theory shows that, yes, you can get all four interactions by the vibrating of tiny little strings. And then you ask another question, and that is the question of immortality. Is it possible that we can use the four fundamental forces in some sense to give us some form of immortality? Well, I'll say a few things about that after the break. Science Fantastic with Professor Michio Kaku. The lines are open. Well, before the break, we had a caller talking about the four fundamental forces, the weak force, the strong force, gravity, and electromagnetism, and whether that's related to immortality. Well, there are two forms of immortality that I address in my book, Physics of the Future. First is biological immortality, literally living forever, and the second is digital immortality. Now, digital immortality is something that we think is actually achievable, and that is by codifying all your memories, all your history, all your likes, dislikes, your credit card history, everything known about you can be digitized, and then we can make a hologram that'll talk like you, that'll act like you, that has many of your memories, and you can have a conversation, an intelligent conversation with this holographic image. And then the question is that really you? Well, to paraphrase our former president, Bill Clinton, it all depends on how you define you. If you are defined as a biological entity, then of course this is nothing but a tape recorder. Very sophisticated tape recorder. But if you are defined as all your memories, your thoughts, all your interactions, your sensations and feelings, if that is you, then you can be reduced to information, and information can be digitized, and you are living forever as a digitized soul. Now, there's the other form of immortality that I address in my book, and that is biological immortality. First of all, as organs wear out, we're going to be able to replace them. In fact, I list all the organs that we can generate in the laboratory today. Skin, bone, cartilage, noses, ears, heart valves, windpipes can be recreated in the laboratory. But what about the brain? That is really hard. But we're now beginning to find the genes that control the brain as well. We have a long ways to go. It's called the Connectome Project. The Connectome Project is trying to figure out the wiring of the biological brain. And then we want to find the genes which can extend our lifespan. So far we found about 60 of them. We know there could be hundreds involved. What we do is we scan the DNA of old people and the DNA of young people. Now that millions of people are having their genes sequenced, we can now use computers to scan the genes of old people and find out where aging takes place. Think of a car. Where does aging take place in a car? Not in the steering wheel, not in the seats. No. Aging in a car takes place in the engine, because that's where we have oxidation. That's where we have combustion. That's where we have moving parts. That's where we have the buildup of carbon deposits. Well, where is the engine of a cell? The mitochondria. And bingo, when you look at where aging takes place in a cell, it's mainly the mitochondria, the energy power plant of the cell. That's where you have errors building up. Now, if we can cure these errors genetically using gene therapy, then in principle, we could live forever. I mean, think, for example, of a cancer cell. We don't like to think that cancer cells are benevolent. Of course, they'll kill you. But cancer cells are immortal. They just reproduce. In fact, they reproduce out of control, forming a tumor, and that's what kills you. That's why cancer cells are so dangerous. But it does mean that cancer cells have a clock, a digital clock that is stopped, and that's called telomerase. We have found the clock and the way to stop that clock. The clock is called a telomere at the ends of a chromosome, and telomerase allows you to stop the clock so that cells just divide forever. Well, what's the catch? The catch there, of course, is that cancer cells also divide forever. That's why we have tumors. That's why you die of cancer. So we still have a ways to go. However, we are now beginning to find the genes that control the aging process. That is remarkable. Okay, well, let's move on to the next listener phone call.
This is John in St. Cloud, Minnesota. I hear you on KNSI. I have a question. The imbalance of matter and antimatter in our universe, could it be because the Big Bang created our universe and an antiverse with more antimatter than matter? I suppose the answer to that question is worth a Nobel Prize.
Well, you're right on both aspects, it turns out there is an asymmetry between matter and antimatter in our universe, which I'll explain. And if you can figure out why there is that asymmetry, you will win the Nobel Prize in physics. You're absolutely right. First of all, antimatter is the opposite of matter. We know that the electron is negatively charged. In fact, it was Benjamin Franklin himself, who gave us the direction of current. He didn't know that the electron was light, therefore it was electrons that move, but it is the electrons that move giving us electricity and has negative charge. Well, there are positively charged electrons called positrons. They are anti-electrons. However, there's an asymmetry between electrons and positrons, and nobody knows why. There should be a balance between the two, but there isn't. Otherwise, we wouldn't be here. So, let's move on.
Hi, my name is Jessica Shimkyu, and I am a mother of 4 autistic children. I believe that I also suffer from autism. 2 of my sons are more on classically autistic side, and 2 on the Asperger's. My question is, do you think that autism is something that comes from evolution? It's just the evolution of man, or perhaps could it be something that is an environmental factor that is causing autism at larger rates? Families like mine with 4 plus, we also realized that there has to be some kind of a genetic connection at this point, but many still wonder if there are any other factors. Thank you so much for your time.
Well, you ask a question that I touch upon in my book, The Future of the Mind. It's a really difficult question because, quite frankly, we are children. We are children when it comes to beginning to understand things like autism and, well, different kinds of mental illnesses and things like that. But let me just say a few things. First of all, Asperger's, as you mentioned, is a form of autism. There's a spectrum of people with different kinds of behavioral patterns. On one end, we have people that are actually functional, can function in society, and some of them go on to win the Nobel Prize in physics and the Fields Medal in mathematics. That's right. Paul Dirac, the greatest quantum physicist of his era, ranking way up there with Heisenberg and Schrödinger. Paul Dirac had Asperger's. He hardly talked at all. Many people used to say that the unit of dullness is the Dirac because he hardly said anything at all. Except when he did say things, he would go on to win the Nobel Prize and open up whole areas. It was he who discovered the properties of antimatter. He was he who discovered the properties of quantum electrodynamics. And he barely talked at all. It was Paul Dirac and Fields medalists. Not one, but more than one Fields medalist in mathematics have also been diagnosed with Asperger's. And so not all Asperger's people are totally dysfunctional. Many of them go on to win prizes and the Nobel Prize in Physics and Mathematics. Now, is it genetic? Is it environmental? Nobody knows. However, there is a definite genetic component because it does seem that autism runs in families to a degree. Is there an environmental component? Well, perhaps. Some people think maybe it's caused by mercury when you visit the dentist's office or something like that, or vaccination. No. It turns out all those reports are apparently wrong in terms of finding a simple environmental link to autism. But remember, it is a spectrum of behaviors, and so one of these days we may find the genetic components of it. On one end of the spectrum are people that talk about things rather than people. They don't make eye contact, for example. Animals, for example, also do not make eye contact. And so talking to an Asperger's person is, in some sense, in a severe case, like talking to an animal that doesn't make contact with you. That's at one extreme. The other extreme gets very emotional and is too much tied to people and not things. So we have many theories. But we have, at the present time, unfortunately, no cure and no guiding methodology by which we can understand it. However, if you get a copy of my book, The Future of the Mind, I talk about what we can do with brain scans of the living mind with regards to certain ailments. For example, schizophrenia. In schizophrenics, people hear voices, and you can actually see the left part of their brain lighting up, which controls voices, and you can actually see that these people are literally talking to themselves without their permission. We talk to ourselves all the time. We do it right now. Even as you're listening to my voice, you're talking to yourself, analyzing what I'm saying. But you're aware of it. The front part of your brain, the prefrontal cortex, is aware of the fact that the left brain is talking to you. However, in schizophrenics, there is a disconnect. And therefore, you are literally talking to yourself without your permission. Now, think about it for a moment. If all of a sudden your brain began to talk to itself without your knowledge and without your permission, you would think you're going mad. And in fact, that's probably what madness is. Madness is perhaps when the left brain does not talk to the front brain, and that is called schizophrenia. Unfortunately, like I said, we are children when it comes to understanding the dynamics of the workings of the mind. But if you want to know what we do know about the mind, get a copy of my earlier book, The Future of the Mind. Okay, well, let's move right along to the next listener phone call.
Hi, I had a question in regards to your Twitter feed on your autographed copy of the book, which was great to win. What do you think of the chances of getting programmable matter anytime in the near future? And if you think if it's a reality, well, it's probably likely a reality, what would the time frame be, and what do you think that would look like? Thank you.
Well, the question is programmable matter. When are we going to have it? What can we do with it? I once saw a movie with Adam Sandler where he was living in a video game. Now, think about that for a moment. A video game, you can stop. You can hit fast forward, rewind, slow it down, speed it up. And if you live in a computer, you could even change the scenery. You can change reality by pushing your hand to the left and pushing your hand to the right, just like you push your screen today. So is that possible? Well, that's possible if you have programmable matter. Now, electrons can be programmed. That's why we have software. What does software do? It programs electrons. But matter is much more difficult to program. Matter is heavier, doesn't move. Electrons are very light and can move in a wire, and that's why we have programmable electrons, and that is called software. That is why we have the Internet. But programmable matter means that you could program reality itself. And you would have the power of a magician. Just like Harry Potter waves his magic wand and can change the atoms around him to create a new reality, that's the promise of programmable matter. To program reality itself. Amazing, right? Now, in Star Trek, we have a vision of this. First of all, in Star Trek, we have the replicator, where you simply go up to a coffee machine and ask for coffee, and it not only mixes the coffee, it creates the coffee out of nothing. In fact, anything you want, you simply ask for, and molecule for molecule, it is created. Now, you may say to yourself, that is fantastic. That is incredible, but impossible. I mean, how could you possibly create something from nothing? Well, it turns out that Mother Nature does it. Mother Nature believes in programmable matter. For example, Mother Nature can take a bunch of hamburgers and French fries and turn it into a baby in 9 months. That is amazing. That is a miracle. Just think about it, taking French fries and hamburgers and creating a baby in 9 months. How does nature do it? First, nature breaks down hamburgers and French fries into proteins and fats and lipids and things like that in your stomach. Then, Mother Nature has the ability to take strands of DNA and cut them at certain places and rearrange them to make copies of themselves, given a blueprint. That blueprint is called DNA, and the cutting mechanism is called the ribosome. Now, if you can create a molecular ribosome, then you too can create reality in your image. Now, can we do that now? Of course not. We are decades away from that. So in Star Trek, we have replicators that can create anything you want by asking for it. But in reality today, we cannot do any of that stuff. Now, there is a group of scientists who are creating a programmable matter unit, a group of scientists who hope to use tiny chips to create programmable matter. So what they do is they get a whole bunch of tiny microchips. Each chip, you have to have a microscope to see, and it has a tiny magnet. And you can program each of these chips with this magnetic field. And by doing that, you can rearrange these tiny little chips into different kinds of configurations. So you may say to yourself, aha, that's the way to do it. Take a bunch of tiny microscopic chips, which are programmable, put a magnet in each one so you can program the magnetic field. Each one has a memory of where it's connected to for the next one, and then voila, you can create something from nothing. Well, that's the dream. That's the hope. However, how close are we to that? I'd say we are decades away from even coming close to programming matter in the way we can program electrons to create what is called the Internet. But once we can do that, it'll change human history. When can we do it? Perhaps in the beginning of the next century. Given the rate at which we're beginning to understand nanotechnology, beginning to understand the ability to manipulate individual atoms, then we may be able to do this perhaps in the next century. But, like I said, don't hold your breath. That's the dream, to program reality in the same way that Harry Potter can wave his magic wand and create something out of nothing. Okay, let's move on to the next listener phone call.
To leave a question for Michio Kaku. My name's Deborah Williams, calling from London. I've always been fascinated with space, and before I found out it was a fabric, I've always been daunted by, is it claustrophobic in space? Not to be in a spacecraft, but actually to be in the blackness. Is it claustrophobic? Thank you. And your books are superb. Thank you. Bye.
Well, I call from London. Thank you so much for the question. And first of all, you're absolutely right. Claustrophobia is a problem for astronauts because of the fact that space is a premium. It costs $10,000 to put a pound of anything into orbit around the planet Earth. It costs about $100,000 a pound to put anything on the surface of the moon, and maybe $1 million a pound to put anything on the surface of Mars. Now, when you send a human into outer space, you have to encapsulate him so that the astronaut has air and life support, food. And, of course, claustrophobia is one of the sensations you're going to be experiencing because space is at a premium. Every square inch of the space station has to be accounted for. And so you're absolutely right that space is at a premium. Now, of course, we have Elon Musk of SpaceX, and we have Boeing aircraft, makers of the SLS booster rocket, 2 heavy booster rockets, not one, but 2 heavy booster rockets that'll take our astronauts into outer space. But how big is their space capsule? Well, we hope to put maybe 4. Not 2, but maybe 4 astronauts inside the space capsule. Not much bigger than the Apollo spacecraft that took us to the moon 50 years ago. In other words, claustrophobia is going to be a problem. And what happens if your life depends upon your next door neighbor and you can't stand him, that he has habits that drive you nuts? That's also a problem. So NASA takes this very seriously. NASA has actually placed astronauts in confined quarters to see whether or not they'll get on each other's nerves, to see whether or not they'll get claustrophobia, because a trip to Mars, a round trip, will take 2 years. Now think about that for a moment. 3 days and you can go to the moon. You can go to the moon at the beginning of the week and come back at the end of the week. That's how close the moon is. Mars is a 2-year round-trip journey. And in 2 years, you can get a lot of claustrophobia, and a lot of people can get on each other's nerves if you're trapped in a tiny, tiny little capsule that takes you to the nearest planet. Okay, let's move on to the next listener phone call.
This is a question for Dr. Kaku. Is it possible that when a supermassive black hole collapses to a singularity and winks out, that it initiates a Big Bang in a new multiverse? And I would like to win one of his new books. Thank you.
Well, believe it or not, there are some physicists who believe exactly what you just said, that a black hole is not the end, that in some sense it could be a beginning. Because even children ask the question, Mommy, Daddy, if a black hole sucks in everything, where does all that stuff go? Well, at the present time, most scientists would say, A, I don't know, but B, perhaps, just perhaps, it could be a gateway to another universe. We'll talk about that after the break. Welcome back to Science Fantastic with Professor Michio Kaku. Well, before the break, we had a questioner who asked the question, if everything falls into a black hole, does it fall out the other end, creating a new Big Bang? Well, as preposterous as it may seem, we physicists have taken that idea very seriously. In fact, a colleague of mine is Alan Guth, a professor of physics at MIT. He may eventually win the Nobel Prize for something called inflation theory, a theory which tries to take Einstein's theory of the Big Bang and quantize it. Well, if a Big Bang takes place when you squeeze matter and it pushes its way through to another universe, then can you do that in a laboratory? That is, can you play God? Well, Alan, believe it or not, has done the calculation. If you take an oven and heat it to super temperatures not found anywhere in the universe today, but temperatures found at the black hole, then a hole may erupt inside the oven, which sucks in the matter from the space and time, and that matter then is sucked into a parallel universe, and it blows out the other end, creating a white hole, and perhaps even another Big Bang. So I asked Alan about this calculation. Of course, you'd have to be godlike to do this. You'd have to have incredible supernatural powers to create something that hot, an oven that hot, to create a hole in space. But he said, yeah, you can do the calculation. It's published in the physics literature, and you have to take it seriously. Now we have a Hollywood movie called Interstellar. The man who helped to create that movie was Kip Thorne, who just won the Nobel Prize in physics, by the way. And in the movie, they do exactly that. They fall into the singularity, and they are blown out the other end. Now, to do this, you'd have to have a technology far greater than anything that we humans can create on the planet Earth. So I thought to myself, if I was advising the movie Interstellar, I would be faced with a problem. Where did the energy come from? Where did the technology come from to create a wormhole, a gateway to another multiverse? Well, they found a very clever answer. If you saw the movie with Matthew McConaughey called Interstellar, they finally tell you where this wormhole came from. It came from our descendants. That is, millions of years into the future, our descendants are so powerful that they're able to open up gateways through space and time and create a time machine. And then they went backwards in time because there was a time in our early history where our world, the Earth, was almost destroyed. So in other words, the gift of the wormhole came from our descendants. Our descendants took pity on us and sent the wormhole back in time, back to our era, so that we can escape and create a world where our descendants could populate it. Well, that's a very clever way of getting around the question, how do you get enough energy to create a wormhole? The answer is, ask your descendants, because they will build a time machine to give you the wormhole from the future. Well, it sounds like Hollywood, right? Well, it is. A Hollywood movie called Interstellar. But the man who helped to advise that movie, Kip Thorne, a colleague of mine, just won the Nobel Prize in Physics. Okay, well, let's move on to the next listener phone call.
Hi, this is Eric calling from 970 KFBX in Fairbanks, Alaska. I was wondering if you could please explain Bitcoin in the absolute simplest terms humanly imaginable. I can Google it, but I come up with all these terms like blockchain, and I feel like I need to be a computer programmer to fully understand this. Could you just expound upon Bitcoin, the relevancy of cryptocurrencies in the future, and Bitcoin's one thing. And it's people are paying $13,000 for a coin, but who's stopping people from setting up 100 different other kinds of cryptocurrencies, with their own different name, and then they, command whatever price they command? I mean, is Bitcoin the future of money? I don't know. Any insight you could provide, help me understand this, would be appreciated. Thank you.
Okay, well, Bitcoin is a wild card, but let me explain. It goes back to the question of what is something worth? Like, let's say I take a glass of water. How much is it worth? Well, if a billionaire is willing to pay $1 billion for a glass of water, it is worth $1 billion. So in other words, things are worth whatever somebody is willing to pay for it. Period. End of story. This means that any object could have any value as long as somebody is willing to fork the money to pay for it. So you could do the same thing for the internet. You can create an imaginary object called the Bitcoin or anything you want, and as long as someone is willing to plunk down the money for it, that's what it's worth. And then when more people come in the game, they say, well, I can speculate. I can put my money in because tomorrow is worth more. Now, does that sound like a Ponzi scheme? Well, in some sense, yes, it is a Ponzi scheme. But is it possible? Certainly is possible, because that's human behavior. Human behavior is such that we like to speculate on things. So as long as you buy a Bitcoin for X dollars and you assume and hope and pray that it will double after a certain period of time, and it does double, well, you can pocket the money. And people have. People who have invested very little in Bitcoin have come out millionaires as a consequence. But again, it's like musical chairs. Musical chairs, you take away one chair at the end of the music until finally you have nobody left. But what happens is things are worth whatever someone's willing to pay for it. But when no one is willing to pay anything for it, it's worth zero, because a glass of water is a glass of water. If people are willing to pay $1 billion for a glass of water, that's what it's worth. But the price could collapse also instantaneously. So who invests in Bitcoins? Well, people who don't like national governments, because national governments cannot regulate Bitcoins because they exist in cyberspace as nothing but digits floating in the ether. And so nations cannot regulate it. So, of course, drug dealers, small-time criminals, they get involved because you cannot track laundered money. And that's one of the advantages of it. So my personal point is, A, we will always have Bitcoin of some sort or another because of the fact that we'll always have petty criminals who want to take advantage of it. B, there are also legitimate speculators. They are speculators, however. They don't create anything of value. There's nothing of value being created because people are simply bidding to get the next level of profit from a Bitcoin. So what's the future of Bitcoin? Well, we'll say a few things after the break. Welcome back to Science Fantastic with Professor Michio Kaku. Well, before the break, we had a question about Bitcoin, the future of Bitcoin. Well, my personal point of view is A, Bitcoins will always exist. There will always be some form of digital currency. B, there could be many of them because many people want to cash in on the Bitcoin craze. But C, it is speculation, pure speculation. There's nothing of value there. There's no gold. There's no stack of gold in Fort Knox that backs up the currency. It's nothing but a promise that yeah, you buy it today and maybe tomorrow you'll make money and maybe you won't. Blockchain helped to legitimize it because the chain involved allows you to track the sequence of events behind the currency, and also governments are beginning to recognize it, and that gave it legitimacy, and that's why it took off. So my advice to you is, if you're a gambler, yes, it is a form of gambling. You may want to get involved, but hey, don't blame me if you get burned, because like all forms of gambling, easy come, easy go. Okay, well, let's move on to the next listener phone call.
Hi, my name is Richard Vesey, and I'm calling from Aberdeen, Washington, and listening to KXRO radio station. And so my question is since stars are different sizes when they're first formed, it makes sense that the condensing of a hydrogen cloud a big enough one, could in fact just turn into a black hole. And of course, E equals mc squared. And this is a little bit unrelated, but 5 billion years or so ago, we have increased dark energy in the universe, making the universe expand quicker. And so what's happening to that equation if the universe is expanding quicker? What's happening to the matter side of that equation? Thank you.
Well, you ask a question that has stumped the world of physics at the present time. First of all, even children know that the universe is expanding. We have this Big Bang theory, and it's part of our everyday vocabulary now that, yes, there was an explosion, but the universe is accelerating. Not slowing down at all. It's accelerating. It's careening out of control. And as it expands, it gets larger. Now, why is it expanding? We think there's something called dark energy, which is the energy of nothing. Believe it or not, even nothing has energy associated with it. And that nothingness has anti-gravitational properties, believe it or not. And it's pushing the galaxies apart. So why is the universe expanding? We think because there's something pushing the galaxies apart. What is it? The energy of the vacuum. Now, the bigger you get, the more vacuum you get. And the more vacuum you get, the more you can push the universe apart. And the more you push the universe apart, you have more vacuum, which means you have more dark energy. So you get a vicious cycle. The more you have, the more you can have. The more dark energy you have, the bigger the universe. The bigger the universe, the more vacuum there is. The more vacuum there is, the more dark energy there is, which pushes the universe apart even faster. Now, you ask another question. E equals mc squared, energy and matter. And it turns out that here, the energy is the energy of nothing. And it's nothingness which is expanding. Now, it sounds bizarre, but that's what the equations give you. The equations give you the possibility that energy comes from the vacuum, and the vacuum is expanding, and that's where this new energy is coming from. Now, let's say we do a calculation to try to calculate the amount of energy there is. The number we get is very embarrassing. It is off from the theoretical value by 10 to the 120. Take a sheet of paper, draw the number 1, and then after that, draw 120 zeros. That is the mismatch between theory and experiment. This is embarrassing. It is perhaps the most embarrassing question in all of physics. Why does the calculated value of dark energy, which causes the expansion of the universe, disagree with the actual value of the dark energy? We don't know. In other words, there's another Nobel Prize waiting for the young person who can figure out where this dark energy comes from. Now, string theory does give you dark energy, but it doesn't calculate the amount of dark energy. There's a fudge factor involved. And so some people are not quite satisfied by string theory's solution. So many string theorists are trying to use string theory to calculate dark energy, but so far no one has been successful. So if you could calculate why we have this mismatch by 10 to the 120, you will get a Nobel Prize in physics. Well, unfortunately, we have run out of time. Once again, this is Science Fantastic with Professor Michio Kaku. Every week, we talk about the cutting edge of science. And if you want to be part of my book tour, go to my website, mkaku.org, mkaku.org. It gives you the cities where I'll be traveling in late February, autographing perhaps your copy of my book, The Future of Humanity, talking about our destiny in outer space as we enter a new golden age of space travel. Next year, we go to the moon. After a 50-year gap, next year we're going back to the moon. After that, we're going to Mars. After that, the solar system. Who knows where we're going to go after that. But it is our destiny to explore this universe of ours. Good day.